In this video we're going to look at drawing tangents to an ellipse. First from a point on the curve and then from a point outside of the curve. Before we can do that we need to locate focal points. Focal points are key pieces of information to do with an ellipse and will allow us to find tangents. They are key pieces, so if we're to take an ellipse and measure half the major axis. If we put the point of our compass on the end of the minor axis, just like this, and swing an arc that cuts the major axis in two places, that gives us our two focal points, F and F1. Why does this work? So if I measure the distance from the focal point to the end of the minor axis, that's equal to half the major. The distance from the same end of the minor to the other focal point is also half the major axis. So the distance from the focal point to the end of the minor axis to the other focal point is equal to the full length of the major axis. Now that applies, so the distance to any point on the curve, so from the focal point to any point in the curve, back to the other focal point, is equal to the length of the major axis. It's what makes an ellipse, in the same way that if you take a circle, the distance from the center out to the circumference is the radius, and that's a constant distance the whole way around. Same thing applies here. Distance from focal point to any point on the curve to the other focal point is always equal to the length of the major axis. So we're using that piece of information, putting the point of our compass, setting our compass to the length of the major axis, putting the point onto the end of the minor axis, swinging an arc, and it'll cut our major axis in two places, here and here, giving us our two focal points. So now we're going to look at drawing a tangent from a point on the curve. So why are our focal points important? Our focal points are important as they're going to allow us to find our tangents. If I take any random point on the curve of the ellipse, so this is a point P on the curve. Doesn't matter where you put it, you can put it anywhere, here, it doesn't matter. Generally in a question we're given it. I'm going to draw a tangent to that point on the curve. So a tangent, as we know, is a line that touches a curve at one point and one point only. So it doesn't cut through it and it's not away from it. It is just passing through that single point and nowhere else. To draw my tangent, what I'm first going to do is I'm going to take from one of my focal points, point P, and extend a line from the focal point through point P. I'm going to do the same thing from the other focal point, so from point F over here through point P. So I now have a line joining from focal point to point P back to F1, and I've extended those through. What I need to do next is I'm going to bisect one of these angles. So if I bisect this angle here or here, so 1 or 2, it'll give me my tangent. If I bisect this line or this line, it gives me the normal to the tangent, the normal being a line perpendicular to the tangent at the point of contact, P being the point of contact. So I'm going to bisect one of these lines out here. So look at the earlier video for your camera if you need a refresher on how you bisect an angle. So swinging an arc, swinging two more arcs, this time keeping them the same size, and drawing a line, the bisector here, join back to point P, is my tangent to the curve. So just talking through that one more time. Bisect the angle that I have formed by joining F through P and extending, F1 through P and extending. I'm going to bisect that angle, and the bisector is the tangent when bisecting this one. If I'm to bisect this angle inside here, that will give me the normal to the tangent, which is a line perpendicular to the tangent at the point of contact. So I'll just do it again one more time at a different point down here. So join F1 to P through my point of contact. So that's when we're given our point of contact. Do the same from F1 and bisect the angle that is formed. So bisecting this angle inside here. And that gives me the tangent. So this is my point of contact. Make sure you label your point of contact, which was given in the question. Extending from both focal points through the point of contact and bisecting that angle, giving me my tangent. Next, we're going to draw a tangent to an ellipse from a point outside of the curve. So this time we'll end up with two tangents coming from a singular point, whereas previously when the point was on the curve we only ended up with one. So this is my tangent, or my point, my ellipse. I have my point P outside of the curve, and I have my ellipse. What I need to do first is I need to locate my focal points the same way that I did previously. So measuring the length of the major axis from the end of the minor, swinging an arc to cut the major axis. So this gives me my focal point. So focal point F and F1. The steps that we need for this are different to what we had for the previous one, but we still do need our two focal points and the point outside the curve. Step 1 on this is I'm going to put the point of my compass on point P, which is the point we're going to draw a tangent to, and the pencil extend that up to the near focal point. So that's here on the near focal point. I'm going to swing an arc that goes through that focal point and out around the side. It's quite large at the moment as I don't know where the other one is going to end up. So point on my point P, pencil on the near focal point and swing an arc. Next, what I'm going to do is I'm going to measure the length of the major axis with the compass, and keeping this distance, so the length of the major axis, I'm going to put the point of the compass on the other focal point, the focal point I haven't used yet. And I'm going to swing an arc so that it cuts the first arc that I've drawn. So that cuts it here and here. So just recapping on this, from P, this distance here, this radius equals P to F1, P to F, and this one out here, so it starts on the other focal point, and this radius is equal to the major axis. So the distance from here back is equal to the major axis, but it starts on that focal point. Where this one here, it starts on point P and is equal to the distance from P to F, to the near focal point. So we've swung our two arcs. They intersect each other at this point and this point. What I need to do next is I'm going to join both of those points back to the second focal point that I used, the one that's furthest away. Here and here. So joining from where the two arcs intersect here, back to the focal point, and this one also back to the focal point. Those two lines cut through the ellipse in two places. So the first one cuts through it here, and the second one cuts through here. Both of these points are points of contact on my tangents. So POC and POC, points of contact. So as I now have a point of contact on the tangent and a starting point on the tangent, I can draw a line from P through that point of contact, giving me one tangent, and from P to the other point of contact also, giving me the second one. So there I have two tangents drawn from a point outside the curve of an ellipse. So just a quick recap again. First step in this is putting the point of my compass on the point outside the curve, extending it until it touches off F, the near focal point, and swinging an arc. The second thing is I measure the length of the major axis, here to here, and put the point of my compass on the other focal point that I haven't used. I swing an arc so that it intersects the first arc that I drew. That intersects it in two places, here and here. And I join those points back to the second focal point that I used. Where those lines pass through the curve of the ellipse gives me 2 points of contact for the ellipse.